to study estimate of variance under stratified random sampling. Let us see. Expected value of small si square is equal to capital Si square. This can be written by using the result of previous chapter. If I speak any particular strata, the results of simple random sampling without replacement holds nicely. So I can write directly expected value of Si square equal to capital Si square, where Si square small, sample means sum of square. And if you write a capital Si square, it is a population means sum of square. This statement says sample mean sum of square is unbiased estimate of population mean sum of square. Formula of Si square is 1 upon small ni minus 1 summation j1 to ni bracket yij minus y bar I whole bracket square. Similarly, we have variance of y bar I estimate under SRS WOR for particular strata I. You can recall the formula. Variance y bar estimate is n minus n divided by n into n multiply s square. Now when I speak for stratified random sampling, same formula you can use, but it is applicable for every strata I. So put subscript I everywhere. That will be the formula for variance of y bar estimate. Therefore, variance estimate of y bar st. This is our estimator of population mean under stratified random sampling. ST stand for stratified random sampling. This equal to summation I1 to k Wi square variance estimate y bar I. As the formula of y bar st is summation Wi into y bar I. When I take a variance, Wi is a constant come out, so it becomes Wi square by your first year knowledge. Variance estimate of y bar I written by this formula. Ni minus Ni divided by capital Ni into Ni whole bracket multiply Si square. This is minus symbol, be remember. So this is a formula of variance of y bar st estimate. It should be remembered that in SRS WR with replacement is used instead of SRS WOR for drawing the sample from each stratum. Then in this case, that means what I wrote, it is under without replacement. Suppose you draw the sample by with replacement, then what is the change in the formula? Y bar st is summation I1 to k Wi y bar I. Expected value of y bar st, we proved y bar. Variance of y bar st is summation I1 to k Wi square. When I say variance of y bar st, I say variance of the right side. Variance of sum is sum of variance. Covariance term is 0. This is a constant, so it comes out with a square. Variance of y bar I, ni minus 1, ni into ni capital Si square. This is under with replacement. Or you can write simply wi square and variance of y bar I in terms of population variance sigma I square upon ni. This is also true, or you can write in terms of mean sum of square. Both are eligible. Therefore, variance of y bar estimate is summation wi square Si square divided by Ni. This is the approximate formula when some population is very large. If population is large, Ni minus 1 divided by Ni become 1. Because if you take Ni minus 1 divided by N, it is 1 minus 1 upon capital Ni. If Ni is large, 1 upon Ni becomes 0. So you get only Ni in the denominator. So this is the approximate formula under the assumption population strata size is large, where Si square means sum of square by sample 1 upon Ni minus 1 summation j1 to small ni yij minus y bar I square. You have to remember formulae nicely. If I say small si square, it is the sample quantity. Now you can see the difference between this formula and this formula. Here I did put the cap. So this is the population quantity written in capital Si square or sigma square. When I put a cap on the measure, it becomes a sample quantity. So it is the estimate of this population quantity. That's why capital Si square written small si square. And formula of small si square is this. Si square 1 upon Ni minus 1 summation I1 to Ni Yij minus y bar I whole square. Now we'll try to study what are the advantages of stratified random sampling over the previous chapter. Data of unknown precision may be required for certain parts of the population. This can be accomplished either a careful investigation to strata. Example for this is, in order to know the impact of hike in petrol prices, the population can be divided into strata like labor income groups, middle income groups, higher income groups, and so on. Obviously, the high income group is more affected than the labor income group. Hike in petrol prices more affected to the people having higher income. The reason, the vehicles which is owned by the higher income group are more than lower income groups. They are purchasing four-wheelers, whereas lower income people purchase two-wheeler motorbikes. And that is why hike in petrol price will affect higher income group people as compared to lower income peoples. So more careful investigation can be made in the high income group strata. This is possible only under stratified random sampling. If you apply previous chapter, we study hike in petrol price for entire population together, and then we draw a sample from entire population. So the result estimate what you will get will never adequate to the entire population. Whereas if you apply stratified random sampling, what we do, firstly we divide the population according to the variable under study. Now my variable under study is to investigate effect of price hike in petrol. So it is quite natural the effect of hike in price petrol does not affect uniformly to each and every individual, and that is why it forced investigator to divide a population into different strata, that means different homogeneous groups, such that every strata will be homogeneous inside and should be heterogeneous between. So I divide population into three parts: people from labor income group, that is a low income group, then peoples belong to the middle income group, and the rest is people belongs to higher income group. And then now what we do under stratified random sampling, we pick up some people from low income group, some people from middle income group, some people from higher income group. And then we combine all these together, named as a stratified random sample. And by using this, we try to predict what is the average hike in the petrol prices and so on. And that is why if the population is heterogeneous, stratified random sampling gives a better result as compared to the homogeneous population. Second advantage is sampling problems may differ in different parts of the population. Number one, it depends on hike in petrol prices. Similarly, there are many problems by which your estimate is going to be affected. For example, to study consumption pattern of households, the people living in houses, hotels, prisons, hospitals, etc., are to be treated differently. That means if you want to study the consumption pattern, it will be vary from type of resident. So according to type of resident, I have to divide entire population into different stratas and then study the problem under study. Third advantage is administrative convenience can be exercises in stratified sampling. Example, in taking a sample of villages from a big state, it is more administratively consistent to consider the districts as strata so that the administrative setup at district level may be used. For this purpose, such administrative convenience and the convenience in organization of field work are important aspects in national level surveys. That means if you are studying problem related to villages, then you can divide your state in different small district levels, and district will work as a strata. Number fourth advantage is full course selection of population can be obtained through stratified sampling. So these are the advantages of stratified random sampling. You can go through it. If you have any difficulty, you can discuss. Near about 10, I put different advantages of stratified random sampling. I put certain remark on theoretical results. Number one, capital N multiply y bar st. This will provide you unbiased estimate of population total. Just like in simple random sampling without replacement, capital N multiply y bar. Now under stratified random sampling, capital N multiply y bar st. This gives unbiased estimate of population total. You can see easily expected value capital N y bar st. N is a constant taken out. Expected value of y bar st is proved as a capital Y bar, and N multiply capital Y bar is a population total estimate. Therefore, Y bar estimate equal N time Y bar st. Number two result, variance of estimator of population total in stratified random sampling. These results we derived from previous what we proved. Variance of N time Y bar st. Here I am speaking for population total. That's why I put capital N multiply Y bar st. If I say estimator of population mean, then I write only Y bar st. N is a constant, comes outside with square. Variance of Y bar st, and this is the formula we derived before. Estimator of the variance of estimator of population total, you have to put cap on this measure. This I kept here, scan is not came nicely. This as it is, summation as it is, this bracket as it is, wi square as it is, only the change of capital SI square becomes small si square. Otherwise, same thing is continued. Allocation of sample sizes Ni from ith strata. This is also called as determination of a sample size from ith strata. In other words, how to decide value of Ni from capital Ni. As per previous chapter, we have seen the topic determination of sample size small n under with replacement as well as without replacement. The same topic continue here. Name is allocation. You may call determination, determination of sample size. Here not small n, here small ni, because from every strata we draw the sample. So how much ni should be taken from ith subgroup of entire population? We have three different approach to decide the value of ni. First approach is called as a proportional allocation, abbreviated as PA. Second is Neyman's allocation, abbreviated as NA. Third is optimum allocation, abbreviated as OA. We'll try to decide small ni under these three different approach. Number one, proportional allocation. The name itself gives a meaning of allocation. Your value of ni is directly proportional. This is the symbol of proportional in mathematics. Ni proportional to capital Ni. Now this proportional symbol transfer to equal by using proportional constant C. So Ni equal to C time capital Ni. Call this equation 1. How to get the value of C? It is decided by using a condition total sample is equal to sum of separate samples. Ni, we derive C time Ni under proportionality. Put it here. C is a constant taken out. Summation I1 to Ni. I told at the beginning N1 plus N2 plus dash dash Nk is a total population. So this summation is nothing but your entire population. So I replace this as capital N. Therefore, what is the value of C? C comes to be N upon N. Put this value of C in equation 1. You get the result of allocation Ni. Ni becomes small n, that is here C equal to capital Ni multiply C, and C we got N upon N. Therefore, formula of Ni equal N time N multiply Ni. You can write Ni divided by capital N as a proportional constant, Pi. Therefore, formula of allocation Ni equal small n multiply Pi, I1 to K. What it says? It says that from first strata N1, your sample will be small n multiply P1, N2 equal to small n time P2, and so on. Variance of estimate of population mean under proportional allocation. This is your general formula. Variance of y bar st original. Now if I want the expression of variance under proportional allocation, in place of small ni, I will replace this formula, or you can replace this formula. You get variance of y bar st under proportional. Let us check how to do that. Left hand side, variance of y bar st equals summation I1 to k. Now this can be written 1 upon ni minus 1 upon capital Ni wi square si square as it is. It is the square. Make a correction. This bracket and this is exactly same. Take the LCM, this goes here, so you get this quantity. Now I multiply wi square si square inside bracket, so you get two quantity. Second term does not depend on small ni, so no change here. Change comes at this point. So I put small ni n time capital Ni upon n here. So we get variance of y bar st under proportional. Up to this line, it is original variance of y bar st. Now here, it is a variance of y bar st under proportional because I replace this formula in place of this ni. wi square si square as it is, this ni in the denominator, so it becomes a reverse. N goes up and this comes down. Minus summation wi square si square upon capital Ni. This is to be written from this. Same formula. Now wi is nothing but Ni upon N. So this Ni and this N cancel with one wi. So what remain? Summation I1 to k wi si square upon n minus summation I1 to k. Here also you can take wi is ni upon n. This ni cancel with this ni. So wi square si square upon capital N. Now you can look summation wi si square, summation wi si square is a common. So what is remain? From here 1 upon n minus 1 upon capital N summation I1 to k wi si square. This bracket, if you take LCM, it will be n minus small n. So you get this formula. So this is your answer of variance of unbiased estimator of population mean under proportional. Now if I want to find estimate of this formula, just write here small si square. That become an estimate of this formula.